5. So now, if we expand on that, and I said this to you guys once before, but what we would like to do is we're going to take that approach of finding the rate of change and determine what we call a normal line. Now, a normal line, listen to me carefully, a normal line is perpendicular to the curve. And so what we're asked to do in example number 5 is to find the normal line of this function at x equals 1. Now, if you're not sure what I'm going to draw the graph, and we'll come back to the graph later. But if I were to graph this, this is going to be a parabola that's turned upside down, and it has a y-intercept at 0, 4. So that's the maximum value. What I'm interested in is what is the normal line. So at x equals 1, I'm going to have a value here. So if I were to figure out what that value is, I'd say f of 1 is equal to 4 minus 1 squared, or 3. So this point right here is 1, 3. And the normal line, so let's do a couple of things. A tangent line, which is based on the slope, which is not the question they're asking us now, but the tangent line goes like this. It touches the curve at one point, all right? That's the tangent line. Now the normal line is perpendicular to the tangent line. The normal line is perpendicular to the tangent line. So that's what I'm looking for. I need an equation for this purple line, y is equal to mx plus b. And it has to be perpendicular to the tangent line. Well, we know from previous examples that the tangent line y equals mx plus b is actually y equals the instantaneous rate of change times x plus b through this particular point. So in order to find the normal line of this function, 4 minus x squared, I have to find the rate of change. Now, if I know what this rate of change is, or the slope of this line, what would the perpendicular slope be? It'd be the negative reciprocal. So for this line, I need y equals mx plus b. But really what I need is y equals 1 over, negative 1 over the rate of change times x plus b at that particular point. Alright, so how do I find the rate of change for this? Well, we're going to go to that formal definition that we've used in the past. So my rate of change of this function is based on the limit as h approaches 0. And I'm going to write it just a little different. I'm going to say f of a plus h. Now normally we use x, but we put a because I'm going to let a equal 1. You could put x in there. The textbook tries to show you that we're transforming it, and when you have a bunch of x's, you get confused. So minus f of a all over h. Well, that becomes, if this is f of x, what would f of a look like? Or a plus h, what would that look like? Well, it'd look like 4 minus something squared. What is that something?
1.
A plus h, right? So I'm going to write down 4 minus a plus h squared, that's that portion, minus f of a, which is really just 4 minus a squared, all over h. And I'm going to leave that alone for just a second so it can soak in.
Soaking.
Do you see what I did there?
Yeah, you just substituted.
I just substituted. Wherever there was an x in the original equation, I put a plus h. And then I substituted again. Wherever there was an x, I just put an a.
So a equals 1, h equals 0?
Well, at some point, we'll plug the 1 in for a. Yep. So now, yeah, and the same for h. So now, if I expand this, I get 4 minus the quantity a squared plus 2a times h plus h squared. So that's all that f of a plus h stuff. Minus, and then over here, I've got 4 minus a squared. All over h. And we're still taking the limit as h approaches 0. Okay? So your algebra skills, you can't make any mistakes because this will take a little bit of time. So I'm going to stop writing this limit as we'll tack that on at the end. I'm going to say then the next step would be is to distribute this -1 through the parentheses, right? And then this is a -1 I'm going to push through the parentheses. So I end up with 4 minus a squared minus 2ah minus h squared minus 4 plus a squared all over h. Now Mr. Adams said any term that does not have an h should cancel at this time. Okay? It should. So this 4 minus 4 is 0. This a squared minus a squared is 0. And then I have minus 2ah minus h squared. Now, the problem with this is that I cannot take the limit of this function by plugging in h equals 0 the way it is. So, but I notice that my two terms on the top also have an h. So if I factor out an h, I get negative 2a minus h all over h. Now that's nice because what can I do with the h's?
Cancel out.
They cancel out, or they reduce to 1 over 1. So now what I'm doing is I'm taking the limit of this thing as h approaches 0, but now I've got 2a minus h all over 1. If I plug in the 0, what am I left with? Negative 2a, and so what was a? 1. So my final answer would be negative 2 times 1, which is negative 2. So I did all of that to figure out that the slope m is equal to the rate of change, which is equal to negative 2 times 1 or negative 2.
Wait.
Questions?
Where did the H go?
We substituted
It magically
in.
disappeared and I plugged in a 0 right here.
Yeah. That was to figure out the slope of the random line. Whatever.
Okay, are there any other questions? Yes?
Can you go back to that like first page?
Yeah. So let's recap, all right? Let's recap and see what we did, okay? Watch what we did. We needed to find the rate of change. So this is how we find the rate of change, this little formula here. Now, it's true, at some point we're going to plug in a equals 1, and then we're going to plug in h equals 0 at some point. But this thing is rigged up in a way that the h's should cancel. Right now I can't plug in the 0 for h because that makes the fraction undefined.
True. Yeah.
I'm going to wait to plug in the 1 because you'll see that we'll get some a terms that cancel, and so it's just extra work. So what I do then is I write my composite function, which is going to be 4 minus the quantity a plus h squared minus the quantity 4 minus a squared all over h. Then I do some algebra, and I get this term. The next step is to push through that negative 1 through the parentheses. And, well, actually I do that twice. I have a negative 1 here I need to push through, and a negative 1 here I need to push through. Okay, are we good up to that point? Yes? No?
That's not what I understand all the math part,
Yeah.
like that stuff, but I don't understand like what you're trying to find, like with that graph that you showed.
Yeah.
And I don't understand at the very top
Okay.
of this page.
Okay. So we're going to get to that. So anyways, shh, careful. Be quiet. Well, be quiet. So as you do the algebra, as you do your algebra, you'll end up to this point, and what happens is, if you've done this correctly, Every term that does not have an h in it will cancel out. That's important. If you don't get that happening, you made an error, an algebraic error. We didn't make any error, so we ended up with 2 times a times h minus h squared, all over h. Now, it's rigged up on purpose because then I can factor out the h. When I factor out the h here and I have a factor of h down here, h divided by h is the same as 1 over 1. That gives me this equation. Remember, all of that stuff was the rate of change. So what I found was the rate of change is equal to -2. So now what does that mean? That means that the rate of change of this pink line, the slope of this pink line at x equals 1 is -2. We did all that work to say that this line right here had a slope of -2. Now, I don't know what x and b and all that stuff is yet. We got to plug that stuff in and solve. But that's what the tangent line would be at x equals 1. Okay? So we need to remember that this is when x equals 1. Now, how could I find the tangent line? Well, we know that when x equals 1, y equals 3. So I could plug in 3 is equal to -2 times 1 plus b and solve for b. If I do that, I get 3 equals -2 plus b. Add 2 to both sides and I get 5 is equal to b. So my tangent line would be y is equal to -2x plus 5. So this pink line is the equation y equals -2x plus 5. And it will cross through the point 1, 3. It will be tangent to my curve of the original function, which was y equals 4 minus x squared. But the question was not to find the tangent line, the question was to find the normal line. But the normal line is perpendicular to the tangent line. So how do I find the tangent line? We need the negative reciprocal slope. What point would I use? 1, 3, and then I could use the point slope form. So another way that you could do this is I could say y is equal to m times the quantity x minus x sub 1 plus y sub 1. And so my y is equal to m. What is the negative reciprocal of -2?
1/2.
Positive 1/2 times x. What was the x term? What point are we going to cross through?
3.
What's the x of that though?
1.
1. And then my y value would be 3 because it crosses through the point 1, 3. So now when I push this through, I get 1/2 x minus 1/2 plus 3. Or 1/2 x plus 5/2, right? Because it's 2 halves, or 2 and 1/2, right? Which is 5/2. So what did I find? I found that this equation is y equals 1/2 x plus 5/2.
Is it better in calculus to leave improper fractions as improper fractions?
Yes.
Mixed numbers?
Yes. We're going to leave a lot of things in improper fractions. We prefer in calculus to have exact values over decimals or mixed numbers. So let me double check my answer in the book, and yep, we did it right. Now, that's a lot of work for one problem. Truthfully though, to be honest with you, we didn't need to find the tangent line, but I dove a little deeper to kind of explain the relationship. Because sometimes we'll find the tangent line, sometimes we'll find the normal line. So all this purple stuff is referring to the normal line, which is what they wanted in the first place. Does that make sense?